Hey everybody, this is Larry. This is day 14 of the July Leetcode Day Challenge. Hit the like button, to subscribe, and join my Discord. Let me know what you think about today's file. So I'm actually in Washington, D.C., in town for a wedding. So congrats to them. But yeah, I don't have much to say. I'm going to do the usual tourist stuff, but most of my time is going to be spent at wedding. So that's why I have a new background. Anyway, today's problem is 105. Construct binary tree from preorder and inorder traversal. Okay. Probably. Okay. I think. Okay, and they're unique. Just want to make sure that they're unique. And it's equal to 3000, so we have to do something at least linear-ish or like n log n-ish. Okay, so the idea here, and I'm not gonna lie, it took me a lot of practice to really understand how to do this one. Or like I keep on like understanding components, but then I had trouble putting everything together. But the idea is that, of course, in order is you go to, root, no, that's the other one, left, root, right, and then preorder is you go to root, left, right. So here we know that the first element, and this is it recursive, right? So this left is not actually this left, but this is like almost like a recursive left in order. So maybe I'll write it that way. It's a little bit clearer. And right in order. This is left preorder, and this is right preorder. But the same thing is the root. So that means that we have look at the preorder one node or the root at a time. We can figure out, recursively, we can look at the left preorder, match that with the left in order, because yeah, and then so forth. And we can kind of do the preorder one at a time anyway, so I think that should be okay. Okay, so then yeah, let's get started. The thing that I always have to do, and so given this root, you have to look for the root in the in order, and if you do a linear search, that's gonna degrade into n squared, and I probably historically have done that, but this time let's do it correctly, maybe. Right, and these things are unique, I think. Yeah, they're unique, so that means that we can just look it up this way and not lose anything. And then now we have parse, say left index and the right index. Let's say that we want to parse left and right index inclusively, right, on the in order, right? This is parse in order, maybe, right? Just to make it even more clear. Okay, and then now the current node that you're looking at is, well, the root is equal to preorder of current, and then now that you use one element, you could consume it. Right? And we start with 0, and yeah, and then now, what does that mean, right? That means that the left, okay, the lookup of the root, this is going to be the index of the in order, right? So this is the middle. What are we returning again? Oh, we have to construct a tree. Okay, so that means that, okay, so that means that we can create a tree node with, well, no, this is the middle index, say. And now we want to parse in order, because then now we know that everything to the left of it is left in order. So let's say left, and then middle index -1, and then parse in order right, middle index +1, right. We have to do some checking, but that should be okay, meaning we have to check that if left is greater than right, we just return none. And then here we have to create a node as well. So yeah, and we can actually just return this directly. So here current node is equal to tree node with the value of root, and then now node.left is equal to this thing recursively, and I think we should be good. And then now we just return the node, which is just parse in order from 0 to length of in order -1. because this is inclusive. I think this is good, or at least an idea. I've been having a lot of typos lately, so hopefully this is good on the first try, and I am not good in the first try. I've been kind of bad about it. I mean, these keep on, all these time does add up, even though this one is a rather minor one. I guess this is a good example case. We have 0 nodes, no 0 nodes. I mean, this is okay. Let me give it a quick submit. Maybe I got it wrong, but maybe that's okay. Okay, cool. Wow, that actually was okay. That's good. I'm not sure if I was confident about that one. Really tired, didn't sleep enough. That's my excuse. But yeah, I mean, so one thing I would say is that this is going to be linear time, linear space. I think it is tempting to say that this is n log n because this recursion of like breaking the middle and divide and conquer, looks very standard. Like you could just analyze it that way and be like, oh, it's n log n or n squared, depending on how you want to analyze it. But this is actually just O of n, I believe, because each node will get processed once, right? Because this lookup once, and so every time you call this, one node gets removed from the list, and otherwise this is O of 1 lookup, right? This every other step is O of 1. So yeah, it's almost like walking through the tree one by one anyway. And if you think about it this way, this is actually a pre-order traversal because we parse the tree and then we parse the left and the right. So a pre-order traversal is going to be O of n in total. So linear time, linear space, and yeah, you can get better than linear space because obviously you have to return the number of nodes, and the number of nodes is going to be O of n, right? Cool. That's all I have for this one. Let me know what you think. Maybe tomorrow I have better lighting. I'll see you later. Stay good, stay healthy, to good mental health. Goodbye and take care.